So today we're going to be looking at relative dating, which is what we already talked about. We're going to be going over that, make sure you understand it. Then we're going to be looking at reading the layers. Your homework is reading the layers worksheet, which is what you will have homework today. We were going to be able to start that and look at that. But right now, what I want you to do is have out a blank sheet of paper, because we are going to be testing your knowledge of what it is that you know and see what it is that you need to study. Patrick, go and sit down. Do not get back up. So I want you to have your notes closed. Close your notes. Notebooks closed. And again, this is not graded. However, it is going to help you understand what it is that you still need to study or what you need to know. And if this were a quiz, how well you would have done. So this is how you study. You study by making your brain think. So you have to make your brain think. So let's do this without our notes. So I want you to listen up to the questions. You're just going to be writing the answers. All right. Relative dating is what scientists use to determine whether an event is blank or blank than another event. So we're going to be filling that in for number 1. That's number 1. You should have the words blank and then the word or and then the word blank. You should be writing down 3 words. Blank or blank. Number 2. With relative dating, there is no blank information. There is no blank information. Number 3, give your definition of law of superposition. Look on your own papers and don't talk. Give your definition of law of superposition. Number 4, a geologic column is an arrangement of rock layers in which the blank rocks are at the bottom. Edison, stop tapping. These geologic columns help scientists define the blank age of the Earth. Geologic columns help scientists find the blank age of the Earth. Now we're going to look at how the Earth's geologic column is formed. There are stratigraphic sections that are pieced together to form what? Stratigraphic sections from around the world are pieced together to form what? Short columns are pieced together to form what? Short columns are pieced together to form what? All of the columns are then put together to form the Earth's entire what? Now let's talk about how rock layers can be disturbed. In one instance, rock layers are placed about in an undisturbed form. However, in some events, there is a break in the crust. What is that called? When the rock layers are broken. Your note shouldn't be open. Sometimes the rock layers, again, are placed upon the earth in an undisturbed form, but then molten rock comes up and then hardens to make its own rock, disturbing the rock layers that were there. What is that called? These two things are considered what type of disturbance? Okay? Again, at times, rock layers lay about the earth in an undisturbed form, but sometimes there are internal forces that causes the rock layer to bend. What is that called? Then you may have rock layers that, again, undisturbed, but those internal forces causes the rock layer to go on a slant. What is that? These two things are what type of disturbance? For number 15, numbers 11 and 14 are younger or older than the rocks they affect. Are numbers 11 and 14 younger or older than the rock layers they affect? You only need to write one word, younger or older. All right? Lastly, you have another disturbance where the gap layer or the rock layer is missing. There is a gap. There's some missing rock layer. Either all of it's missing or some of it's missing. What is that called? There are two ways that rock layers become missing. One is where the supply was cut off and it never got placed there. And the other is there is some rock layer there, but some of it got washed away or uplifted by wind or water. Are we good? All right, let's get ready to grade our work. Number 1 asked, relative dating is what scientists use to determine whether an event or an object is, raise your hand. Edison? Young or old or young. Then another object. That's here, we're looking at these two. There is no what information. There's no what, Rogerlyn? No absolute information. What does relative mean? Side note, what does relative mean, Bryson? Close. No numbers, just close, order, older, younger, near. What's your definition of the law of superposition? Your definition. Layers on the bottom are older than the layers on the top. Layers on the bottom are older than layers on the top? No. You could have just given me that chorus. Always. Always younger. No. Always young, above, old. What do you think the purpose of the song is? I don't want you to change it now. I want you to be able to check it wrong so you know what you need to look at later. That's why I gave you the song. If you know that lyric, you know that right there. That's the law of superposition. Geologic columns are an arrangement of layers in which the blank rocks are at the bottom. Older rocks are at the bottom. Oldest, older, doesn't matter. Geologic columns help scientists define what type of age of the Earth? Relative age of the Earth. Then we talked about, nope, well, estimate's fine, yeah. Then we talked about stratigraphy, and we're saying that strategic sections are pieced together to form, Edison? Not yet. Yes? Columns. What kind of columns? Long, short? Short. We got to get the short columns first. Then those short columns are pieced together to form longer columns. Remember, the question is asking, how are geologic columns formed? We got little ones, then bigger ones, and then all the columns are pieced together to form Earth's geologic columns. Because that's what we're looking at, geologic columns. Short columns to long columns to geologic columns. Now we're looking at the ways rock layers can be disturbed. This is here where the rock layers are broken. That is called a what? A fault. Oh, you broke it. It's your fault. I said that a million times in class. Where you have molten lava pushing into the rock layers, that is a intrusion. Faults and intrusions are called? Features. Yep. Intrusions and faults are called features. Really, why do you think I gave you the song? And then you have where your rock layers are bent and buckled. That would be folding. And you have where your rock layers are slanted. That would be tilting. Tilting and folding are called events. All right? Tilting and events and features are younger or older than the rocks they affect. Younger. Because the rocks had to be there to be affected. The third type of disturbance where there is a missing rock layer, whether some of it's missing or all of it's missing, is what? Unconformity. Unconformities are formed either where it's none at all, meaning rock layer never got put there. What would that be? Nope. Non-deposition. That's the real word for it. Or some of the rock layer, or even maybe all of the rock layer got moved away by wind or water. Erosion. Let's count up. We'll do this out of 20. If you had all of them right, then you would have gotten 100. If you got one wrong, we're going to do it out of 20, just to make it simple. If you got one wrong, it would have been a 95. Two wrong would have been a 90. 3, 85. You're going down by fives. 4 and 80. 5 is 75. 6 is 70. 7 is 65. 8 is 60. All the way down. If you got below an 80, you really, really need to study. Do that by two ways. Understand the song and know the song, Ladrika. Or look at your notes and study like we just did here, where you're trying to fill in these blanks. If you got above an 80 and you just missed some, then you need to focus on those things that you missed so that you don't get them wrong next time. Any questions about that? All right, then I want to look at the bottom of your notes right here. Without talking, guys. Now, this picture says interpret your notes using the law of superposition. The law of superposition states what? Always young above old. Younger rocks always lie above older rocks, which means the older rocks lie where? Below younger rocks, correct? Now, we are going to be labeling this picture with these letters identifying rock layers. The oldest letter is at the bottom. The youngest letter is at the top. Now, in order for us to do that, we have to identify some things first to make this picture make sense to us. Because right now we look at the picture and we're like, wait a minute, what are we labeling? So the things that we need to actually label, we're going to put a little note on the side that's going to tell us before labeling rock layers, what do we do? So I want you to write before I label rock layers. And you're going to write down some rules that you're going to do before you label rock layers. Number one, you're going to identify features. What are features? Madison. Huh? Both of them. Intrusions and faults. when we're labeling the rock layers, we have to label not only the layers, but we have to label the intrusions and the faults, because those are things that become part of the layers. Tilting and folding, we do not have to identify that in labeling our rock layers, because that is just changing the rock layer. Does that make sense? But the intrusion and the fault becomes a piece of the rock layer. For instance, if you bend your body, I don't need to identify that as your identity, but if you get a scratch on your face, that is now part of your identity. You understand that? Okay, so we need to identify the features. Number 2, identify the layers, and I'll tell you what I mean by saying that. This helps the picture to be a little bit clearer to us, okay? So let's first start off by identifying the features. What features do we see in this picture? Bryson? We definitely see an intrusion. This would be your intrusion. Right? And sometimes you can actually outline it if you want to give you a better indication of what it's actually affecting. Okay? Do we see any other features on this picture? Jayla? A fault. Where is it? Come point to it. Okay? You want to darken your fault so that you realize that it is a fault. And then you can label it if you want. Now, when I say identify your layers, sometimes you can use a colored pencil or just a pencil just so you can mark and see. But you have a rock layer here. Is this area the same as that rock? Yes, it's the same as that rock. Is this area the same? Yes, look at the pattern of it. That's the same rock. All right? Remember, with the break, the rocks shift a little. So that's why they're not totally lined up. Now, in identifying our rock layers, what about this rock layer? It's there, and it's here. You see that? Okay. And then we also have, you don't need a color pencil right now. Right now you can actually just put little shapes in it if you want, so you can see it. We have this rock layer here that I'm highlighting in purple. Is that the same over here? Yeah. Yes. Okay. Then we have this rock layer with these little dots in it. What do you mean, where is it? We also have, I'll color this one pink. Just making it better identifiable on mine. No, those are not faults. Good question. Those are not faults. Those rock layers have been tilted. That's why we label the faults. Faults are breaking. This has not broken anything. All right? And then, lastly, you have your brick rock layer. Now, we do understand, or let me ask you, do you understand, what's this stuff up here? Land. This is land. This is not a rock layer. Land in a house, that's the surface. Down below is the rock layer. So we got that. Okay? So now, we need to be able to label these rock layers. The oldest would be labeled B. The oldest, it tells you right over here, the oldest is B. I've already listed the oldest, we just now have to label them. Which one would be the oldest? Orange, the orange rock layer definitely is the oldest. At the bottom, and it's being affected by whatever can affect it. Right? What's next? Patrick, well, which one is C? Because we know C's next. But which one do you think C is, Patrick? The one in the green. I agree. That's easy enough, right? What do we think we have next? Devin? Purple one was D. Everyone agree?
No.
What do you think should be next? Well, how can the intrusion be next when the intrusion affected D? How can the intrusion come before the rock layer it actually affected? Remember, it's hot molten lava. If there's something there, then it's going to affect it. If it wasn't there, then it couldn't affect it. All right? Now what's next? Yeah. The brown and the purple and the blue are, the brown and the pink and the blue are slanted. Those aren't faults because they haven't broke anything. Yes, Devin? You think the intrusion's next?
No.
Yes, you have to identify the features because they do count. Those become part of the identity of the layers.
But it's younger than the other layer, so the next one.
If you think the next one, okay, let me say this. Shh. Somebody thinks that the next one is the dotted brown. If that were the case, the intrusion would affect it. It must not have been there if the intrusion could not affect it. Do you understand that? We could not put a rock, if that brown rock layer was there, the intrusion would have burnt through that as well. If the intrusion didn't burn through it, then it wasn't there. What do you think is next? You think the intrusion's next? Let me ask you this question. Let me ask you this question. Is the intrusion, does the intrusion become rock?
Yes.
Yes. So if it becomes rock and it hardens, if there's a break in the layers, can the intrusion be broken?
Yes.
Yes. Was the intrusion broken?
Yes. Yes.
Is there a break across the intrusion?
Yes, the fall. No.
Is the intrusion broken?
No.
If the intrusion were broken, then there would be intrusion on both sides of the fault, correct?
Yes.
So can the intrusion is the intrusion before or after?
It's after the little break.
It's after the fault. So which one is older, the fault or the intrusion? The fault is older. So therefore, the fault would be letter what? M. Do you understand that? Because if the intrusion were there, the intrusion would have been broken as well because it turns into hardened rock, which means that you would see intrusion pieces on both sides of the fault. We got that? Okay. We don't see intrusion pieces on both sides of the fault, so therefore the intrusion could not have been there when those rock layers were broken. Now what's next? Now the intrusion. So what letter is that? A. Remember, that's a break. So when the intrusion came about, it stopped at the fault because that was a little break. All right. Now what do we have? The dotted brown, which is E. The pink would be F. What's G?
Blue.
And what's H?
The new layer.
That's not land. What's H? The brick layers.
Wait, rocks? That's bricks?
It just look like that so you can see it. All right? Any questions about that? So you do understand it, right? All right, so now what I want you to take out is you're reading the layer sheet. Now we're going to go over some of this because this is going to be your homework. Shh, why are we talking? Yes. Yes. Not right now, not in the middle of instruction. Why are you not? Where's yours from yesterday? Yes, you did. Go ahead and get one, but you got one yesterday. All right, someone raise your hand and read to me the first paragraph. Here, Janie, go ahead.
This one, right? Okay. Stratigraphy is a branch of geology that studies Earth's history has revealed the sedimentary rock layers. Sedimentary rock is a type of rock that is formed by sedimentation created at the Earth's surface. From within bodies of water and about 3 layers of the Earth's surface.
What is the important word in that paragraph? Duran. What? What? No, it's not the same thing. Stratigraphy. All right. How do we know that that's an important word? Because it is underlined. So therefore, I want you to circle it, highlight it, put smoke bombs around it, whatever you need to do to know that it is important. That word is underlined as important because what does that paragraph tell us?
It's about explaining about
What it is. It tells us what it is. Now, let's look at our directions. And they say, study the below diagram and try to interpret the geologic history of this area. Use the below principles that geologists use in relative dating of rock to explain the reasoning for your answer to the following questions. Now, let's look at these principles first. Because some of you will get caught up and confused on what the principle is telling you. And I want to use something called deductive logic, which means you look at what's there, the obvious, and you read deeper into what that is actually saying. So, the first principle says, the oldest rock is on the bottom if the layers have not been disturbed. That also could mean that the youngest rock is on the top. The youngest is not at the bottom if it just told us the oldest is at the bottom. So you flip around the difference. If it's telling us the oldest is at the bottom, then the youngest must be at the top. Principle number 2 says, an intrusion is younger than the rock layers it cuts through. Therefore, the rock layers must be what than the intrusion? Older than the intrusion. The rock layers that have been affected are older than the intrusion. Number 3 says, a fault is younger than the layers it breaks. Therefore, the layers broken by the fault must be older than older than the fault. An unconformity is an area where erosion has removed some of the rock layers. Is that the only way an unconformity happens?
No.
Also what?
No. Erosion.
Non-deposition. Now, in this particular picture, there is no non-deposition here. We see the rock layers, therefore they're there. All right? However, there are some unconformities, meaning things have been eroded. Now, let me ask you this. If you have rock layers that have been laid upon nice and neatly and smoothly, then those are going to form flat surfaces, correct?
Yes.
If the surface was flat and is now jagged, you know what may have happened. Erosion. Something happened. There's been some movement of that rock layer, which means that that is now considered a what? Unconformity. Stop just throwing things out of your head and think about what you're saying. You know erosions are unconformities. So, when we look at this picture, really quickly before we go on with interpreting it, notice how, excuse me, notice how these layers have flat, I'm sorry, I don't know why that didn't go right on the line. Notice how these layers have flat surfaces. Do we see that? They're flat. But notice how these layers, this layer is jagged, right? That tells us what? Erosion. There was an unconformity. There's some erosion going on there. So over time, something happened where some of that may have been removed. All right. So what were the things that I told you that you needed to do first before identifying the layers of the rock? Christasia. Identify features. So that's one of the first things that we need to do is identify the features. So let's look at this picture and let's just do just that. What are some of the features or any of the features if there are any features on there? Give me something, Edison.
The fault.
Where's the fault? Give me the letter.
E-G-L.
What? No.
Oh, H.
H. And sometimes you can draw right over it as well. Notice it's pointing to it as H. Okay? Is there anything else, Bryson? What letter? Intrusion, A. All right? Anything else? Any other features? No. What was the second thing I told you to look for?
Look for the events.
Look for the events. Did I say look for the events?
No.
No.
Identify layers. Identify layers.
I never said identify events. We identify features. We now need to identify layers. We do not need to identify events because that does not affect that does not put anything extra into our layers. The intrusion adds something to our layers. The faults add something to our layers. The events just shift our layers. All right? So, identify our layers. Do we need to identify E? It's already been identified, right? Yeah. G is identified everywhere. L is identified. C is. A is M.
Yes.
No, because M's also over here. Isn't E and what? No. They look like similar rocks, but they're not the same thing. That's why they're labeled. M is also on this side of the intrusion. What about D? Is D totally identified? No, it's also over here on the intrusion. This helps you get a better picture of the picture, better seeing of the picture. Is J totally identified?
Yes.
Yeah. We have it here, here, and here. Is N totally identified?
Yes.
K,
Yes.
D,
Yes.
and F.
Yes.
So we're ready, right?
Yes.
Okay. So now, let's look at number 1 of our homework. The oldest fossil would be found in rock labeled F, E, J, or D, and identify which principle helped you figure out that answer. Right now, I want you to talk to your face partner or your shoulder partner if you don't have a face partner. Brian, move over next to Akaya and talk it over. Patrick, come move back here next to these gentlemen. All right, I don't want to take too much time on this. Simon, the oldest fossil would be found in rock layer. Well, let's first of all say, do we understand that the oldest fossil would be in the oldest rock?
Yes.
Okay, so the oldest fossil will be found in rock layer F, E, J, or D, Simon? E, because E is the oldest rock. So E would be perfectly fine. What principle answered your question? Okay, let's do it now. What principle? What is the only principle talking about rock layers? The principles are right at the top of your paper. We have I, 2 I's, 3 I's, or IV. It's 1, 2, 3, or 4. I, little I. That's the principle that's helping us. Leave that chair alone. Because it tells us the oldest rock is at the bottom of the layer. So we understand that that's the principle that helps us understand that. Number 2, do with your face partner or shoulder partner really quickly. Ryan and Akaya, you should be talking to each other. Ryan and Akaya, you should be talking to one another.
I. We already said no.
Jamil, quiet. Jamil, I said quiet, Jayla. We're quiet now. Jamil, the youngest rock is labeled K, E, A, or F. F. What principle, Duran? The first principle, because that's the only principle that talks about rock layers. Number 3. Which is older? Igneous intrusion A or fault H? Talk amongst your group.
It's A or H. It gotta be H. Oh. It's H because A didn't win it. So it's open. It's A
Ray. All right, up here. Jayla, you should only be talking to your face partner. Ray, you think H is older? How many of you agree? H is older. Now, without the principle yet, Ray, Drew, without giving me the principle yet, explain to me in your own words why H is older. I said Drew.
Well, I said H is older because first of all it's at the bottom, and then second of all the intrusion, the more that it breaks through the other one, the younger it is. So
Not giving me enough information. Ray, chime in and help him out.
I said H is older because it goes to the oldest rock, the big rock.
So does A.
It also goes to the top.
So now you got to use more words and elaborate because you're on the right track.
I'm putting them together.
Elaborate.
Oh, okay. So H is going to the oldest side, and it's back to stop. And A is continuing to go up to the younger one.
Exactly. Notice that your your fault only breaks E, G, L, and C. So does A. A affects E, G, L, C, but A also affects M, D, and J, which means that M, D, and J were there for A to affect, which means that, do you think M, D, and J were there for H to affect? No, they were not there, so therefore H is older. What principle was that for you all, Drew? Principle 2? Principle 2 says an intrusion is younger. Intrusion is younger than the rock layers it cuts through. Well, it's not. This is only dealing with the intrusion and the rock layers. Is there a better principle?
Yeah.
Which one? Eddie. A fault is younger than the layers it breaks, which means that I guess you can use 2 or 3. 2 or 3.
I think it's good.
2 or 3 is fine because we're dealing with both the intrusion and the rock layer. The intrusion is younger than those rock layers that the fault affected, so that's good. And the fault is younger than many of the ones they break. They're younger than the ones that they've broken, but we put the intrusion into there, so either or would be fine. Now, your homework is going to be to finish the rest of the front, but I want to make sure you finish the rest of the front. I want to look at the back because I want to look at some on the back to get you started with that. Alrighty? We're going to look at this one here. What were the things I told you to first do? Identify the features. What are the features? What letter is an intrusion? Okay, so we got B as an intrusion. Anything else? You don't think A is an intrusion? A is also an intrusion. There's no fault. A fault would just be one line breaking. A is an intrusion, and so is B. What's the second thing we need to do? We already identified the features. We just did that. Rock layers. Do we need to identify any rock layers? Yeah. This is C, and that's C. That helps us to identify what's being affected. You don't tell me anything yet. Sometimes it's air pockets. Yes, that's just the way the picture worked. All right. Right now, talk to your face partner and your face partner only, unless you have a shoulder partner. You do not have a face partner. And you are going to come up with the oldest to the youngest. Not loud. Talk low. All right, my turn. My turn because it doesn't take this long. Akaya, tell me the oldest rock layer. C. What comes next, Brian? A. And then obviously B. C is affected by both. A is affected by B, and B only affects everything else. Any questions on that? Then your homework is to also complete the rest of these. You have time to work on it in class right now. Go ahead and work now. I want you working on it right now, but work on it now, and then if you have to use it later, yes, you may work with your face partner.